Dear students, so we have discussed working of half-wave rectifier in the previous session. Now let us discuss one more circuit, that is two output precision rectifier. So in this circuit we can get two outputs. Let us discuss the operation in brief. So you are applying input to inverting terminal. So always polarity of the output is opposite to the input signal. During positive half cycle, Vi is positive during positive cycle, so Vi is positive, and this is positive, V naught dash is negative, and this is negative. So this particular diode is forward biased, this is reverse biased, because here anode is getting negative potential, and this is reverse biased. So this is forward bias, it starts conducting. Now observe this part of the circuit. If you observe this part of the circuit, applying input to inverting terminal and feedback is negative. Hence, this op-amp acts as again inverting amplifier. So when it acts as inverting amplifier, so you are going to get the output here, which is equal to output VB is equal to R4 by R1 into Vi with negative sign, because gain multiplied by input gives output. So with negative sign because inverting amplifier. So minus R4 by R1 into Vi. If R4 equal to R1, then we know VB is equal to minus Vi. So VB is equal to minus Vi. So let us write here VB signal is equal to minus Vi. If plus Vi input is plus, VB is negative. But what is VA? VA is 0 because diode is reverse biased. 0. Okay. During negative half cycle of input signal, VA is negative and this is negative. Negative. V naught dash is positive. This is positive. This diode is forward biased. D2 is reverse biased. Therefore, VB is 0 here. So VB is 0. VB is 0. VB is 0. But what is VA? Let us see. So this starts conducting. Then upper part of the circuit you observe. Again, this acts as inverting amplifier. You are applying input to inverting terminal. Again, feedback is negative. Op-amp acts as inverting amplifier. Therefore, what the output voltage is equal to gain multiplied by input with negative sign. Therefore, VA is equal to minus R2 by R1 into Vi. Okay. If R2 is equal to R1, so Vi is equal to minus Vi. Since Vi itself is negative during negative half cycle, minus of minus Vi becomes plus Vi. So that Va is equal to plus Vi. Okay. Again, as cycle repeats, we'll get 0, again positive, like this. You will get negative, again here it is 0. And what is the signal? So at VA, you are getting only positive half cycles. At VB, you are getting negative half cycles. Means you are getting two outputs. One is positive DC voltage, other is negative DC voltage. You are applying AC here, but output is DC. This is how you are getting two outputs. Positive DC voltage, negative DC voltage. Suppose if you want plus 10 volts, minus 10 volts DC, then you can use this circuit. Next we'll go for precision full wave rectifier. Very important circuit. Carefully all of you observe here. Full wave rectifier, two op-amps are used here. So during positive half cycle of input signal, Vi is positive. We are applying input to inverting terminal. So V naught dash is negative. When this is negative, this diode is forward biased. This is reverse biased. When this is forward biased, again you observe this part of the circuit, it acts as inverting amplifier. When this acts as inverting amplifier, you get VB here. So VB is equal to what? Gain multiplied by input gives output always. That is minus R2 by R1 into Vi. You can see here. VB is equal to minus R2 by R1 into Vi. Okay. So if R2, what is R2? I have taken 2 times R1, very important condition, 2 times R1. Then R1 get cancelled, and you get minus 2 Vi. VB is equal to minus 2 Vi. VB. What is VA? VA is directly connected to Vi. Therefore, VA equal to Vi. Okay. So VB is equal to minus 2 Vi, but VA equal to plus Vi during positive cycle. Then VA, VB you got. What is the second op-amp? Actually, it is a summer, inverting summer. when two or more inputs are applied to the op amp, one of the input terminals of op amp, it is a summer. Since you are applying input to inverting terminal, it's a inverting summer. So V naught equal to VA plus VB. Output of this op amp is equal to sum of these two with the negative sign because you are applying input to inverting terminal. So VA plus VB. Substitute here. Substitute. Simplify. You get V naught equal to plus VI. So V naught equal to plus VI. So during positive half cycle of input signal, output is equal to Vi only. So V naught equal to Vi. V naught equal to Vi during positive half cycle. Then what is during negative half cycle? During negative half cycle of input signal, input is negative. When this is negative, output is positive. When this is positive, this diode is reverse biased. When this is reverse biased, VB is 0. VB is 0. Okay. Then what is VA? VA equal to minus VI because this is directly connected. Why it is minus VI? Because input is negative. Minus VI. VA equal to minus VI. VB is 0. Then what is V naught? V naught equal to sum of these two with negative sign. Now go for this. So you observe here V naught equal to minus of VA plus VB. Minus of. So what is VA? Minus VI. What is VB? 0. Gives what? Minus into minus plus VI. So that means you are getting during negative half cycle of input signal also what is V naught equal to plus VI. So you are getting negative half cycle also plus VI. That means conclusion is during positive half cycle you can see here during positive half cycle of input signal V naught equal to plus VI. Plus VI means V naught is positive. Okay, so V naught is positive during positive cycle. During negative half cycle also V naught is what? Plus VI. Plus VI. Like that cycle repeats. So hence during both positive and negative half cycle of input signal, polarity of output voltage remains same. So it is not changing. Hence rectification is possible. It is converting AC signal into DC signal, and it is full wave rectification because in both the cycles of input signal we are getting the output signal and the two positive half cycle. Hence we are getting positive DC voltage. If you want pure DC, you can use filters. This is how now op amp can be used as a full wave rectifier. So we have discussed 3 circuits in 2 sessions. First one is half wave rectifier. To avoid the saturation problem, we have used another saturation non-saturating position half wave rectifier with 2 diodes. The next circuit we discussed 2 output rectifier where we will get 2 outputs. One is positive DC, other is negative DC. Then this circuits we discussed just now, which is position full wave rectifier. So I'll send the notes. Please study once again. Thank you for listening.